If you've ever tossed a small pebble into a pond, you know it sinks to the bottom in an instant. Yet out on the ocean, massive cruise ships carrying thousands of people glide over the waves as if they weigh nothing at all. It feels like a contradiction. How can a tiny stone drop like a lead weight while a 250,000-ton mountain of steel stays right on the surface? Keeping that much weight above the waves comes down to three things: how the ship is shaped, what's inside of it, and how it stays balanced from the inside out. To understand how it works, we have to look at buoyancy. You can think of it as the water's upward push, the same force you feel when you try to shove a beach ball under the surface and it pops right back up. This happens because of a simple trade-off. Whenever an object enters the water, it has to move some of that water out of the way to make room for itself. As the water level rises, it pushes back against the object, trying to reclaim its space. There's a specific rule for staying afloat. The ship has to move a volume of water that weighs the same as the ship itself. As long as it can push away enough liquid to match its own weight, the water will hold it up. Mastering that upward push is what prevents a city made of metal from dropping to the bottom of the sea. The first hurdle is the material. Steel is incredibly heavy. On its own, a thick sheet of metal will sink every time, so engineers have to find a way to move a massive amount of water without being dragged down by its own weight. Look at the difference between these two objects. They are made from the exact same amount of steel. The solid block on the left sinks like a stone, but the steel on the right is shaped into a wide, hollow bowl, and it floats. By giving the steel this shape, it captures a large pocket of air. Air is much lighter than water, so when you look at the bowl as a whole, the steel and the air together, it becomes less dense than the water it's sitting on. A cruise ship is essentially a giant version of that bowl. While the outside is made of heavy metal, the inside is mostly empty space. It's a vast shell filled with bedrooms, hallways, and theaters, and all of that trapped air keeps the ship light for its size. It's the same reason an iceberg stays at the surface. Even though an iceberg is huge, the ice is less dense than the liquid ocean around it. The ship works the same way. Because it's mostly air inside, the total structure is lighter than the water it's trying to move. By building a hollow frame, designers make a massive steel structure behave like it's lighter than water. But even with all that air, the ship still weighs hundreds of thousands of tons. The next challenge is making sure that weight doesn't simply slice through the water like a knife. You've seen this in action if you've ever skipped a stone. A round pebble drops immediately, but a flat, wide stone glides across the surface because its shape helps it stay on top. Designers use that same idea for the hull. Instead of a narrow, pointed bottom, cruise ships are built with a wide, flat base. This wide base spreads out the ship's massive weight. Instead of all that pressure pushing down on one small point, it's distributed across a huge area of water, allowing the upward push of the ocean to support the ship more effectively. This shape ensures the ship rests on the water rather than piercing through it. However, these ships are incredibly tall. With 15 or 20 decks stacked on top of each other, they look like they could tip over the moment a strong wind or a large wave hits them from the side. To prevent that, engineers hide a stabilization system deep in the very bottom of the ship called ballast tanks. It works like one of those bottom-heavy inflatable toys. No matter how hard you push it over, the heavy weight at the base pulls it back upright every time. Ships do this by pumping in millions of gallons of ocean water into tanks at the very bottom of the hull. This adds a massive amount of weight to the floor of the ship. This water acts like an anchor. It moves the ship's balance point much lower, closer to the waterline. This ensures the ship stays steady and upright, even when waves are pushing against the side. Without that heavy water in the basement, the ship would be far too top-heavy to handle the open sea. When you look at the whole picture, the mystery of the floating city starts to make sense. It's a combination of three things. Trapped air makes the ship light for its size, a wide hull spreads the weight across the water, and heavy ballast tanks keep the whole thing balanced. A cruise ship is a shell of air and steel that rests on a wide base, held upright by the very water it's sailing through. The next time you see one of these giants on the horizon, you'll know the physics keeping it there. If you found this look at the ocean interesting, share it with someone who's always wondered how these ships work, and subscribe for more. See you next time.